treat the 2 as a fraction itself. So here what we want to do, we want to get rid of all of our fractions. So they're all numerical values. So you have 8, 4, 5, and 1. So you need to find the smallest number that's a multiple of all of those. Okay, so 4 is a part of 8, so we don't even need to worry about that. If we just take our largest number, 8, and find multiples of that until it happens to be a number that's a multiple of all of these denominators, we'll have our solution. So what multiple of 8 is also a multiple of 5? 40. Okay, so that's going to be our LCD. So if we multiply every term in this equation by 40, we'll get rid of our fractions completely. So 5 goes into 40 8 times, so you get 8 times this x, minus 4 goes into 40 10 times, you get 3x times 10, or 30x, equals 2 times 40 is 80, and then finally 8 goes into 45 times, so you get minus 5 times this numerator x. Okay, so we've gotten rid of our denominator here. What we can now do is just combine all our like terms. So if I move the x's all to one side, here I get a negative 17x, and I have 80 remaining on the right. Solve by dividing both sides by negative 17, and I have my solution. X is negative 80 over 17. Once again, it's useful to plug this in, but really you're just testing in the rational expressions. Would this value of x give us division by 0 here? No, and so you're okay for that. All right, in the second group, okay, right here you have a proportion, right? You have one fraction set equal to another fraction. Okay, so you can solve this just by cross multiplying. So here if we take 7 times x minus 3, it's a different color. So if we take 7 times x minus 3, set that equal to 1 times x plus 5, and then just solve. We can distribute our 7 through. Subtract an x from both sides, grouping all our like terms together. Add 21 to both sides. And when we simplify and solve, we can reduce this fraction to 13 over 3. And that would be our solution for x in this case. So again, if you have two fractions set equal to each other, it's a proportion you can just cross multiply. All right, so our final problem here, again, if you think of this as its own fraction, in order to solve this, we need to multiply by the LCD. In this case, it's the binomial x plus 1. We distribute that to each of these fractions and see what the result is. When we distribute it to this first fraction, the x plus 1's cancel, leaving just a 6. In this second term, 5 times nothing cancels, x plus 1. And then in the last term, again, the x plus 1's cancel, so it's a minus 6x. So when you solve for this, you get 6 is equal to, distribute our 5 through, 5x plus 5 minus 6x. Combine our like terms here, we move the constants over, leaving a 1. Combine our like terms, negative x, so we get x is equal to negative 1. So once again, because we were dealing with this rational expression, we want to test and make sure, would this value of negative 1 give us division by 0 if we plugged it into the original form? Yeah. So that means this is called an extraneous solution. It means that negative 1 works in the math that we use to solve it, but it doesn't work in the restrictions of the original problem itself. So our answer actually has to be no solution. Okay, the one solution that we would get mathematically doesn't fit into the restrictions of the problem itself, so that is not a solution. And so that's how you would answer this.